We thank Dr. Rezaifa for his great speech. And now, ladies and gentlemen, it is my distinct privilege to introduce Dr. Mohammad Shekarchizadeh, a luminary in the field of concrete technology and the head of the Iranian Concrete Institute, as well as a professor in the University of Tehran. Dr. Shekarchizadeh's dedication to advancing the science of concrete is evidenced by his prolific research contributions focusing on the innovative use of zeolite in concrete. With numerous publications and authored books to his credit, he has not only expanded the boundaries of knowledge, but has also pioneered sustainable solutions for the construction industry. Today, we have the privilege of learning from Dr. Shekarchizadeh's wealth of expertise and experience. Please join me in extending a warm welcome to Dr. Mohammad Shekarchizadeh.
Good morning, everybody. Firstly, I have to thank Professor Khalu for organizing this conference. Actually, the application and the use of zeolite as natural pozzolan is relatively low compared to other natural pozzolan in the world. Mainly that's because the source of pure zeolite is not available in all over the world. And in some countries, you can find pure zeolite with a high reactivity. Fortunately, in Iran, especially near Semnan, in the east of Tehran, we have a huge resource of zeolite, and it can be considered as a national asset, in fact. And I think in the future, this kind of pozzolan can help us to go toward sustainable concrete. In 2004, for the first time in Iran, we started working on zeolite as a cementitious material in University of Tehran. And since 2004, we did many projects, many research studies, many high-level students who were working on zeolite, and I think this can help us in the future more than in the past. My colleague, Dr. Ahmad Ahmadi, now he's assistant professor at BHRC, Building and Housing Research Center. In fact, we were working together in 2004, and during these 20 years, we were working and we did many projects, as I said. Another person is Azar Humayun, who is now my PhD candidate, and he helped us especially for this presentation. So the purpose of this speech is to explore the potential of natural zeolite as a sustainable and effective supplementary cementitious material in concrete, and the outline is a brief overview about the properties and the benefits of using natural zeolite in concrete. What's natural zeolite? Firstly, it's a natural pozzolan, but its morphology is quite different from other natural zeolite. It's a hydrated aluminosilicate of alkaline and alkaline earth cation with a three-dimensional frame structure. it's, in fact, zeolite has a very huge, internal surface, which can give it different properties, which I will explain after. So the chemical formula, you can see it, and the key minerals is clinoptilolite, especially because there is, in fact, more than 50 kinds of zeolite in the nature. But this type of zeolite is more usable in concrete. The form, firstly, we have to know that when we use some material instead of cement in concrete, it should be, should be crystalline, and it should be glassy and amorph material. But zeolite has a special type of morphology. It's cryptocrystalline. It's not crystalline, it's not glassy and amorph, it's cryptocrystalline. And this kind of morphology gives this material to be more reactive than glassy ones even. And zeolite are believed to intensify the hydration process. Well, two special characteristic of zeolite is high internal surface area, which can help us, for example, when we have a problem of bleeding or segregation in concrete. This high internal surface can give us a good concrete with a good viscosity, and especially for controlling bleeding, we use it in, for example, self-compacted concrete, and it can somehow control the viscosity and plastic intensity. And another thing, it's ion exchange. It's especially interesting for us in ASR, alkali silicate reaction. I will explain it after. The source of natural zeolite, it can be found in volcanic region, and a major producer in the region is in Iran and Japan, South Korea, China, and also in USA. As I said before, a huge amount of zeolite can be found in near Semnan, in Aftar, and another area. The processing is mining, crushed, sorted, and milled to the appropriate particle size. The fineness of zeolite should be about cement, about 300 square meter per kilogram. In different countries, the natural zeolite is used as a pozzolanic material. For example, in China, about 30 million tons per year is used in cement industry. In Turkey, Germany, Italy, Russia, and USA. Historically speaking, it's said that in a very ancient building in what we call Roman concrete, they used, in fact, they mixed the zeolite with lime, and they produced Roman concrete. Zeolite tooth lime mixture have been widely used in the ancient times, in Europe especially. Benefits of using zeolite in cement applications is to enhance mechanical properties, and also durability and effectively eco-friendly by reducing CO2 emissions. Firstly, about the effects of zeolite in microstructure, because everything we see in macro, it's in fact in the base of micro in concrete and other materials. So zeolite can affect the hydration process by different, in fact, styles. And for example, zeolite can act as a nucleation site for cement hydration products and also accelerated the early stage of hydration and finally leading to densification of cement matrix. Well, as a pozzolan, what would be interesting for us is pozzolan activity, and pozzolan zeolite reacts with calcium hydroxide like other pozzolans for produce more durable concrete. And we did TG thermogravimetry testing in BHRC, and we compared, in fact, the different types of natural pozzolan like Tras, Pomis, and Tuf, which are existing in different areas in Iran. And as you see here, zeolite has more TG percent. After 30 days, it's 54, more than 54%, which is more than other natural pozzolan. Effects of zeolite on mechanical properties. All the mechanical characteristics can be influenced by zeolite, compressive strength, tensile strength, flexural strength, elastic modulus, and impact resistance. Just an example, we did some studies in concrete water cement ratio 0.4 with a dosage of zeolite 5, 10, 15, 20%, and we compared these results with silica fume concrete with a replacement level 5, 10, and 20.4, 20.5%. And here you can see the mixture proportions with 400 cementitious materials. And here you see the results about compressive strength. We can see that about 15 to 20% of replacement of zeolite can give us good results compared to control concrete, but evidently it's less than silica fume concrete. But as we know, silica fume is a high and super pozzolan, and it's less than silica fume, but relatively it's good results as a natural pozzolan. About creep and shrinkage, which is very important in dimensional stability. Well, because of refinement of pore structure by zeolite and formation of additional hydration products, all of them can minimize the long-term deformation and dimensional changes. So we can say that zeolite modifies concrete and maybe exhibit reduced creep and shrinkage. In fact, we don't have many results in the literature about creep and shrinkage. The results are not so high, but it's one of the aspects that we can work on it in the future. In terms of durability, which is very important in the concrete area, As you can see in different aspects of durability, mainly ASR, the zeolite can act a good impact, resistance to chemical attack, fusion tower resistance, and how zeolite can react in ASR. As I said before, by high internal surface area, zeolite can absorb alkaline, which are very dangerous in ASR. So by absorption of alkaline, zeolite can mitigate the ASR and also decrease the sodium and potassium ions concentration in pore solution of hardened cement paste through ion exchange. So it's different in a kind of exchanges between ions. The ions which are existing already in zeolite structure and sodium and potassium ions coming from cement. So it's a sort of ion exchange. And by this exchange, we can decrease the damage of alkali-silicate reaction expansion. So in ASR, I think zeolite could be very interesting. And here you can see the results that we have obtained in CMI Concrete Material Institute at University of Tehran. As you know, ISTM 1260 is the main testing for ASR. And you can see it's very high potential. We had, in fact, a very high potential rocks, call it control. After 40 days, the expansion was more than 0.45. It's 2 or 3 times more than acceptable expansion. And in using zeolite, 5, 10, 15, and 20%, we can see that the ASR damage and expansion is totally limited. And here, as I said, it's very interesting. For us, the durability in Persian Gulf area is very important for concrete durability, and we did a very important investigation since more than 20 years ago in University of Tehran and other institutions in Iran. We had 2 sites in Bandar Abbas and in Qesh Island, and I presented here just some experiences using zeolite in mixtures in Qesh Island. In March 2008, 62 specimen with mixed proportion. Again, we have 400 binder and cementitious material with water cement ratio 0.4, and we compared 5% of silica fume, 5% metakaolin, and 10% of zeolite. We put our specimens in different areas in Persian Gulf, and the high risk and the high dangerous area is tidal zone, in fact. After many, I think maybe 2 years, we can see no difference, no significant difference between silica fume and metakaolin, which is very important for us. That means that zeolite can act like methacholine and zeolite in tidal zone, and same results we obtained for silica fume methacholine, and even in some area better performance for zeolite. The surface chloride, which is important in durability investigation in Persian Gulf area, we can see that the amount of chloride in surface area in zeolite, it's somehow same or even less than methacholine and silica fume. So for that study, just that we saw that total chloride content of concrete incorporating natural zeolite was lower than that of the control concrete. However, at the same level, silica fume can perform better than the natural zeolite. And the use of natural zeolite for improving the durability of concrete in aggressive environment like Persian Gulf is promising. We talked about the benefits of zeolite, but we have also some challenges and limitations. About the challenges, again, due to high internal surface for fresh concrete, we have reduction in concrete workability. That means in using zeolite in concrete, we have to use superplasticizer because the water can be absorbed by internal surface, high internal surface of zeolite, and we can loss of workability and slump. And that's why we have to use superplasticizer. Here you can see in increasing the amount of zeolite, we have to increase also the amount of superplasticizer. One thing which is important is that chemical admixture industry has to adjust the amount of different component in the superplasticizer to find the best superplasticizer for each kind of cementitious material. And that's why we started some study to find the better one, and we found that in fact the inclusion of 3-polyphospholate type retarder was an efficient measure to mitigate the workability loss of natural zeolite, blended mortars. But I think we have to investigate more and more because we have a very important deposit of zeolite, and I think chemical admixture industry in Iran, in fact, has to work to find the best formulation for using, zeolite concrete for zeolite. Another thing is setting time. Adding zeolite to concrete may affect its setting time in hardening process, and it requires some adjustment for concrete process. Another thing is the consistency in performance. It's the same for every natural pozzolan. When we use something from nature and for mines, we have to have a very special quality control and to be sure in terms of consistency of the product. And about the limitation, availability and cost. well, generally speaking, depending on location demand, because now we are talking about zeolite in Semnan. When we want to use, for example, zeolite in very far distance, so the transportation costs should be considered, and maybe it would be some in another area in Iran, the deposit of zeolite, but now we are talking about Semnan. So the availability and the cost of zeolite should be considered in using, and also the precipitation and acceptance of zeolite by concrete industry should be considered. About the history of research and application in Iran, as I said before, in 2004 we started for the first time working on natural zeolite, and the first MS thesis conducted at the University of Tehran in 2007 with Mr. Dr. Ahmadi, and the first publication in Cementitious, it was 2007. The first journal paper was 2010, and it's more cited paper in zeolite all over the world. In fact, it's more than 500 citation. The first published review, it was in 2012 in Handbook of Natural Zeolites. Also, we published the first national standards called Zeolite Portland Cement in 2013. And as I said, the University of Tehran is the first, and after another institution, and the number of the documents in the world. About the application of zeolite in project in Iran, first we started the research in marine field exposure in 2008, and in real construction, it was in Amir Kabir Tunnel in Tehran in 2009, the first time we used zeolite in concrete, and in the precast concrete limits in Imam Ali Artish segment bridge, again in Tehran in 2015, and the first time using zeolite in ready-mix concrete plant is by FAO Beton Company in 2018. Here you can see the field exposure station in Reshma Island in 2008, and still we have some results from this exposure site, and here is Amir Kabir Tunnel, city center in Kerman. Also we used zeolite. Some segments, bridge segment, and in ready-mix concrete, especially for SCC, precast slab, and also precast slab in self-compacted concrete and exposed concrete project. For future research, optimization of zeolite content and particle size, again we have to work on it. Understanding long-term durability in different area, and investigation of synergistic effect with other materials, and assessment on environmental impact. And finally, we can integrate the digital technology, utilize digital technologies such as machine learning, computational modeling, and visual prototyping to optimize zeolite concrete formulation. At last, I wanted to respect the late professors who worked a lot for concrete science and concrete industry and concrete design in Iran, Professor Galibafian, Professor Ramazanianpour, and Professor Zahedi. Thank you for your attention.
Now now we've got time for just one question. If you have any question that occurred to you during Dr. Shekarchizadeh's speech, now you have the time to ask the man himself and be answered. Anybody, any question?
تشکر آقای دکتر از زحمات شما. من یه سوال خاصی داشتم. شما اولا زئولایت حالا شبیه حالا متاکولین یه تفاوتایی با هم داره. اولا شما به صورت دونه بندی تو طرح اختلالات استفاده کردن یا تو دونه بندی سیمان ازش استفاده کرد؟ یه سوال هم این که گفتین کریپتو کریستاله، یعنی آمورف نیست، کریستالی معمولی هم نیست، کریپتو کریستاله. این دونه بندی متاکولین با زئولایت چه تفاوت داره؟ ما یه کاری هم یه جایی داریم انجام میدیم با سرباره فولاد. خب سرباره فولاد هم حالا همون قابلیت‌های متاکولین و زئولیت تا یه حدی داره. همین از اونها استفاده کنیم در آینده چجوری؟
بله، عرض شود که در خصوص دانه بندی که این یه آسیابه دیگه، یعنی در واقع اون کارخونه که تولید میکنه اون زئولایت طبیعی رو آسیاب میکنن، ولی مثل بقیه پوزولان ها که تو استانداردم اومده که نرمیش باید لوشه سیبان باشه، این اون انجام میشه. حالا پارتیکل سایز که منحنیش و اینا رو ما خیلی روی این کار نکردیم، یکی از موضوعاتی که میشه کار کرد و کلا ما فکر میکنیم که برای یه سیمان آمیخت تو کشور یکی از کارهای جدی که باید انجام بشه همینه که ما بتوانیم پوزولان های طبیعی که داریم جای مختلف کشور اینا رو با پارتیکل سایز های مختلف در بیاریم و یه جوری ادجست بکنیم با پارتیکل سایز سیمان. خیلی به جواب خوبی میرسیم، هم توی فرش کانکریت هم توی هاردن کانکریت. درسته؟ پس این موضوع که میگید نرمی و ما کلا بگیم مثلا عددی حدود مثلا 300، ولی فراتر از اون اگه بریم تو حوزه پارتیکل سایز و مثلا چقدر بین 2 میکرون و 10 میکرون و اینا هست، این چیزایی که باید دید. یه نکته مقایسه‌اش هم با متاکولن، باز متاکولن ما وارداتی بود اون پروژه که انجام دادیم، چون میدونیم متاکولن ما تو ایران تولید نمی‌کنیم، داریم یه سری معادن کولنی که مناسبه، ولی خب توی صنعت چینی اینا خیلی ارزش افزوده‌اش بیشتره، به همین جهت ما اون استفاده نمی‌کنیم، ولی اون نرمی شاید بیشتر باشه متاکولن از زئولایت که خب اصلا از دستور خارجه، چون تو پروژه همونطور که عرض کردم باید وارد کنیم و دیگه نمیشه. ولی مقایسهش با سرباره یکی از ویژگی‌های ارزشمندش تو بحث هیت آب هایدریشن، یعنی کاهش حرارت هیدروتاسیون که تو پروژه‌های مختلف جواب داده. توی زئولایت ما حداقل من الان ذهن نمیتونم بیارم که چقدر میتونه کنترل به صورت یه نچرال پوزولان خوبه که کلا خب حرارت هیدروتاسیون کاهش میده، ولی اگر شما بخواید یه جایی بونن سرباره به خصوص تو حوزه کاهش حرارت هیدروتاسیون استفاده بکنید، به نظرم آزمایش‌های حرارت هیدروتاسیون حتما ضروری. حالا شما اگه واضح‌تر بگین که کاربردی که الان مثلا سرباره استفاده میکنید و قاعدتاً بحث اقتصادی هم مطرحه دیگه که از اینا چقدر الان وقتی که من میدونم قیمتی که زئولایت وجود داره تقریبا قیمت سیمان که قاعدتاً باید کمتر باشه، ولی خب اون عرضه کننده در حد اون بسته بندینا که میکنن در حد قیمت سیمان عرضه میکنن، باید دید سرباره با اون چطوری میشه و به خصوص کاربرد رو ببینید کجا میخواد استفاده کنه. خب حتما این گرونتره، نشون ماسک حتما گرونتره سرباره، یعنی مثلا حدود 250 تومن ایناست تونش. خب حالا ببینید دو تا قصه رو از هم جدا بکنیم. شما این موقع راجع به سرباره راجع به دانه چیز اگریگیت استفاده میکنید، خود زئولایت رو هم شما میتونید دانه بندی یا اگریگیت بهش بدید، مثلا در حد ماسه و درشتونه و به عنوان یه سبک دانه استفاده بکنید چون سبکتر از سنگدون است، ولی خب اون ارزش افزوده‌اش بیشتر اینه که به صورت پوزولان استفاده بشه. یاد میکنید یعنی بیایم ما گرین بکنیم و در حد آسیاب کنیم در حد سیمان. سرباره هم همینطوره، سرباره هم شما البته سرباره ذوب‌آهن مال کورهای بلند اینا ارزش پوزولانی داره، یعنی ارزش جایگزین سیمان داره، ولی مثلا سرباره فولاد مبارک اصلا نمیشه به عنوان جایگزین سیمان استفاده کرد، باید حتما اون اگریگیت استفاده کرد که بهش میگیم استیل سلای یا سرباره فولادی. توی سیمان سپاهان و سیمان ناین و اینا استفاده میکنه. بسیار خوب، اگه دوستان سوالی دیگه نداشته باشن بسیار خوب، متشکرم.
Before we move on with our next stage and our next session, let's take a quick 30-minute break. And the exhibition has just started, so I welcome you all to visit the exhibition as well. فارسی هم بگیم که دوستان زمان استراحت رسیده، یه نیم ساعت یه نفسی بکشیم و نمایشگاه هم که بیرون هست لطف کنید که به اون هم سر بزنید.